Notes on writing absolute value equations. In this lesson, we will be learning how to write equations given the solution on a number line. We have solved absolute value equations graphically and algebraically. Now we are going to do these backwards. We will start with the number line solution, and we will be finding the absolute value equation with that solution. Technically, there are many equations that will give the given solution. We will be working with absolute value expressions that do not have dilations. This means that the coefficient of x will always be 1. This way, we will all find the same absolute value equation. Let's start with the equation given. The equation, the absolute value of x equals 2, means that x's distance from 0 is 2. So if we start out here in the middle of our graph at 0, we would go out 2 in either direction to get to our solutions. That's what makes our solutions to the equation -2 and +2. They're graphed on the number line as solid points. If we wanted to take this graph and shift this graph 3 units to the right, our center would now be right here at 3. How do we shift a graph 3 units to the right algebraically? We subtract 3 inside the absolute value bars. What is the new equation? Well, it used to be the absolute value of x. Now it's going to be the absolute value of x minus 3 to shift the center of our graph 3 units to the right. We're still going to go out the same distance of 2 in either direction, so now we'll have the absolute value of x minus 3 is equal to 2. If we're going to work backwards to write an equation for number 1, the first thing we need to do is figure out where is the center of our graph, and then we're also going to work what is the distance that we go out in each direction. When we write our equation, we're going to have x minus whatever the center is, and then on the right we'll put the distance. So first we need to figure out what is it that's halfway in between 8 and 22. We could do this algebraically by averaging 8 and 22. That would give us 15. So 15 is in the center of our graph, and thus we need to shift our equation 15 units to the right. To determine the distance that we need to go, we need to figure out how far we go from 15 to get up to 22, which is 7. That should be the same distance we go from 8 to get up to 15, which is also 7. So that's a good sign we found the right middle. And 7 is our distance. Pause the video while you attempt to do number 2. To find the center of the graph, I average -3 and 15 by adding them together and dividing by 2. The center I got for my graph is 6, so the left side of my equation is the absolute value of x minus 6. Each of these numbers is 9 units from 6, so that means my absolute value is equal to 9. Pause the video while you try number 3. For number 3, the average of -10 and 80 is 35. So our absolute value equation is x minus 35. Then on the right side, we need the distance from the center. We went 45 units in each direction. So on the right side of our equation, we have equal to 45. To do number 4, we're just looking for some general terms of how we write an absolute value equation. If we know the center of a graph, on the left side of our equation, we're going to have x minus whatever the center is. Then on the right side, we're going to put in the distance that we went from the center to get to each of our solution points. For a final point to realize, sometimes when we find the center of our graph, it may be at a negative value. When this happens, we'll have x minus the center, or x in this case plus 9, because how do we shift 9 to the left? We put a plus 9 on the inside. However, when we go to do the distance, a number's distance will always be a positive number of units, so on the right side of our equation, we should always equal a positive.